Good morning, all. We are discussing about magnetic forces. We have seen that the attraction or repulsion in current carrying wires is not electrostatic in nature. The force is magnetic. So we are discussing about magnetic forces. Now we will see what is the force experienced by a moving charge when it is placed in a magnetic field. Suppose a charge capital Q moves from A to B in a uniform magnetic field with velocity v. You consider a small element dl along the path. Now, since it is in a magnetic field B, certainly the charge will experience a force, magnetic force. What is that force? What is the force experienced by the charge Q when it moves in a magnetic field? The expression is given by Lorentz law. Lorentz law states that the force experienced by a charge when it moves in a magnetic field B, it is nothing but F mag, that is equal to Q into V cross B, where V is the velocity. This is the case when there is only magnetic field is present. Now, you assume that there is electric and magnetic fields are present. Now, in the presence of electric and magnetic field, the Lorentz force law becomes, in the presence of electric and magnetic field, the Lorentz force law can be written as F is equal to Q into E plus V cross B. This is the force experienced by a moving charge. If it is placed in a magnetic field only, it is given by Q into V cross B. And if there is both electric and magnetic fields are present, this F can be written as Q into E plus V cross B. Now, in the present case, the charged particle is moving in a magnetic field only. Then the magnetic force is given by Q into V cross B. Now, let us calculate what is the work done by the magnetic force. What is the work done by the magnetic force on the moving charge? We have seen the charged particle Q is moving from A to B. Now, what is the work done? Let us calculate the work done when it moves a small distance dl. When the charged particle Q moves a small distance dl with velocity v, now we can write the velocity v as dl by dt, displacement by time, dl by dt. When Q mu moves an amount dl, the velocity is nothing but dl by dt. From that, we will get an expression for dl as v dt. Now let us calculate the work done by the magnetic force on a moving charge. We can always write the work done as force into displacement. When the charged particle moves a small distance dl, the work done dw becomes this F magnetic dot dl. From Lorentz law, we have F magnetic equal to Q into V cross B, and dl is nothing but v dt. Now substituting the value of F magnetic and dl, we have the expression for the work done by the magnetic force is given by Q into V cross B dot V dt. The value of V cross B dot V dt is equal to 0. Why? This is because V cross B dot V is 0. See the figure. V cross B is a vector that is perpendicular to both V and B. And if we take a dot product of V cross B with V, we are taking the dot product of two vectors that are mutually perpendicular. Therefore, V cross B dot V is equal to 0. Since V cross B is perpendicular to V, V cross B dot V is 0. Hence, dW becomes 0. So we can conclude that the magnetic forces do no work. The magnetic force do no work. Magnetic force may alter the direction in which the particle moves, but they cannot speed it or slow down. That is why we are calling the magnetic force do no work.